Hi everyone. So let us talk about assignment 3. Basically, in this assignment, there are two things what you have learned in class is something called Gauss elimination or Gauss-Jordan elimination method to solve a system of equations or uh, something called row reduced Echelon form or Echelon form. So this assignment is about that. If you don't know the definitions, I will prefer you to look some book like, for example, linear algebra by Fredberg or by Sheldon Exler or this yeah, I mean, there are many other good textbooks available. These are like uh, some of those. Okay, so what you have to do in problem first, you have to determine if your given matrix is in row reduced Echelon form or row Echelon form or neither of them. So the first one is C. The matrix, let me copy 0, 0, 0 minus 3, 0, 0, 0, 4, 0, 0, 1, 2. Okay, so you might have used the word pivotal in class. So pivot means, something crucial or important. So it's that entry below which you convert every other entry to be zero. So what you should have for row reduced Echelon form or before that row Echelon form, in row Echelon form, you should have a staircase kind of thing, right? So what you do, you directly go to the first row of the matrix and you see the first non-zero entry. What is the first non-zero entry? This. And below this, you make everything zero, right? Is it the case here? No, right? So this is not a row Echelon form. Sorry for this spelling. It should be H, Echelon form. Since it's not an Echelon form, it cannot be also row reduced, right? Row reduced Echelon form. So it's none of them. Okay. The question is, can you make this by some row operation? Think about it for a moment. So the operation will be you interchange row 1 and row 3. If you do that, what you will get is, let's see, 0, 0, 1, 2, 0, 0, 0, 4, 0, 0, 0, minus 3. Okay, now what is the first non-zero entry of the first row? This. Everything below should be 0 if you want to make it row Echelon form, right? Now go to the second row. What's the entry? First non-zero entry, this. Everything below it should be 0. Or if you want to make it a row reduced Echelon form, so what you have to do, everything above and below should be 0 and this 4 should be 1, right? So let us reduce it in row reduced Echelon form. So what are the operations needed? So first operation you will do is you will change R2. So this is your pivotal element 1 here, and this is your pivotal element for now 4. You will apply this operation. So now what you are getting is 0, 0, 1. Circle always pivotal element. I like to do that to have a track. And this will be 1, right? And then 0, 0, 0, minus 3. And now you have to apply row operation such that this minus 3 should be 0 and 2 should be 0 because you are talking about row reduced echelon form. So what will be the operations, guys? R3 you will change like this. So R3 plus 3 into row 1, oh sorry, row 2, and R1 you will change how? Depending upon this. So R1 minus 2 R2. So if you apply these operations, this will become in which form? Row reduced echelon form. So one I am just circling to denote that these are pivotal elements. So this is the row reduced echelon form. And if you just want a row echelon form, you don't need to do this. You just have to make the entry below 4 to be 0. Okay, very nice. Let us do the second part. So the matrix is 0, 1, 0, 5, 0, 0, 1 minus 4, 0, 0, 0, 3. Now, let's come to the first row. Look the first non-zero entry. Oh, it's 1. Is everything below 0? Yeah, below 1 I mean. Okay, let's go to the another row. Let's see what's the first entry. First non-zero entry I mean. Oh, it's 1. Is everything below that is 0? Yeah, it is. Okay, let's go to the third row. What's the first non-zero entry? This. Is everything below? There is nothing. So yeah, well, this is, yes, this is row echelon form. I mean, this matrix is in row echelon form. Is it a reduced one? Below 1, everything is 0, above 1, and this is 1. Here also, above, below 0. But this 3, this is not 1. And above 3, the entries are non-zero, right? So this is not a row reduced echelon form. You got it? Okay. Let us see another. So what, and you know how to convert it. Now I will leave that as an exercise. How to convert it in row echelon form. It is already row reduced echelon form. Okay. 1, 0, 0, 2, 0, 0, 1, 3, 0, 0, 0, 0. Again, let's go to the first row, first non-zero entry. Oh, it's 1 and everything below and above is 0. Let's go to the second row. It's here. Ah, it's 1 and everything above and below is 0, right? Let's go to the third row. Oh, there are no non-zero entries, right? So you are done. That's what you want, right? It's a staircase like this. So this implies this is yes. The matrix is in row reduced echelon form. Definitely, if it is row reduced echelon form, it is row echelon form, right? Every row reduced echelon form is in row echelon form, but converse is not true. You have an example, just this second part, and you also have an example in which there are none of them, right? The first example. So see, these questions are very wisely chosen by Sir. Okay, let us come to the problem number 2. So some matrix is given to you guys. So let me copy that matrix. 1, 0, 3, minus 3, 1, 4, 4, 2, 2, 5, minus 1, 5. Now let us see what you have to do. So you have to find the matrices by, he has given some operations. You have to apply those operations and see what are the you know, corresponding matrices. So A part is interchange second and fourth row. So basically R2 you have to interchange with R4. What you will get, guys? 1, 0, 3. First row is same, right? Now the fourth row will come 5 minus 1, 5. And then um, third row is same, 4, 2, 2. And then you have the second row, minus 3, 1, 4. That's all. Now, so there are three parts. I think we have to deal with this separately. We don't have to do in the same matrix. So B part is multiply third row by 3. So what should be your operation? R3 interchanges with 3 times R3. So what will happen, guys? So first row will be same. Second row will be also same. And here 4 into 3. What is 4 into 3? 12. 3 into 2, 6. 3 into 2, 6. Fourth row will also remain same. Similarly, you have to perform the other operation. What is the other operation? Adding minus 3 times the first row to the fourth. So to the fourth row, okay, you are adding minus 3 times first row. Now you know how to do this. Shall I do? Okay, I will just find one entry of the row 4 only. So this is 5 plus minus 3 into 1. This and this, right? So what it is? 2. Rest entries you can find, and there will be no change, right? No change in this portion. Okay, very nice. Now, what is the next task? The next task is you have to find row echelon form of the given matrices. So first you have given this 0, minus 1, 2, 3, 2, 3, 4, 5, 1, 3, minus 1, 2, 3, 2, 4, 1. See, since you have to go row by row and look for the first non-zero entry, and if the column one you see, there are rows where first non-zero you have uh, the first entry to be non-zero. So better you interchange it. So let me do this. So R3, I want to interchange with R1. I mean, you can do R2 with, you know, R1 also. That's also fine. I just want to have one above. That's all. 1, 3, minus 1, 2. This will be same. 2, 3, 4, 5. And then what? Here you have interchange, right? 0, minus 1, 2, 3, 3, 2, 4, 1. Note that you have to find a row echelon form, right? You're not asked to find the reduced one. So I just have to make this will be my now pivotal element, right? I just have to make entries below this element 0. So I have to make this 0, I have to make this 0. So how to do that, guys? So you have two operations, right? R2 you will interchange with R2 minus 2R1. And similarly, R4 you will interchange with R4 minus 3R1, right? So let us make the matrix properly. So first would be same 3 minus 1, 2. Second, 0, right? So it is R2. So 3 minus 2 into 3 is minus 3. 4 minus 2 into minus 1. It is what? 6, right? So you have to do this like by entry. So 5 minus 2 into 2. This is what? 1. So don't skip calculations, write it properly and do it. It will be good for you. Otherwise, you will make silly mistakes. You may make. Okay, there is no change here. And then this one. So this will be 0. And this is 2, right? 2 minus 3 into 3. 3 into 3 is 9. And you have 9 minus 2, which is 7, and with a minus sign. Okay. Then 4 minus minus 3 means 4, 5, 6, 7. Then 1 minus 3 into 6. That is minus 5. I don't like calculations, but it's okay. We have to do. No, you know, nothing we can do here. Okay, now go to the second row. Okay, this is the entry. Now what we have to do? We have to make these two 0 below this minus 3. Let me just verify your definition. I may forget, your definition of row reduced Echelon form. Actually, you will see later on why you are doing this. It helps you to solve system of linear equations when you put it into matrices. But um, you know, uh, what I was about to say, I forgot. I actually forgot. Uh, Yeah. So this helps you to solve system of linear equations. So that's why we do these linear, row operations. And there is some fixed strategy. If you make metrics like that, it would be, you know, your life would be easy. But it's your choice. Sometimes you may not, you may not make metrics like that. That's also fine. Like while solving, it depends like what you want to do. Okay. So let me do this. So what you have to do, you have to make this and this 0. So what you will do with row 3, so let's say what you do, you multiply it by 3, okay, row 3. And then what you do, there are other ways also. One will say row interchange, you do interchange of row 2 and 3, and then multiply the second row by minus 1, and then do the same thing, one and the same thing. However you want to do. So 3 into row 3 plus if you do row 2. Let's see what you get. So 1 is same, 3 minus 1, 2. There is no change in this row also. Now here, what you have? This will become 3. Okay, maybe I need a minus here. Yeah, see? So 3 into minus 1 minus minus 3. So it is what? 0. Now similarly this. So this will be 3 into 2 minus row 2. That is 6. This is 0. Wow. And then this element, this is 3 into 3, which is 9. 9 minus 1 is what? 8. Okay. So this is your pivotal element. This is your another pivotal element. Now what you have? 0 minus 7, 7 minus 5. Now let us change this also. Okay. So when you do this, how to do that? R4 changes to, see, just, multiply by, say, 3 R4 minus 7 R2. That's all. So this will give you, minus 7 in place of this, you will get 0. So let us see what's happening. 1, 3. minus 1, 2, 0, minus 3, 6, 1, 0, 0, 0, 8. And let's see what you have here. This will be 0. Let us see what is this. 7 into 3, 21, minus 7 to 6. What it is, guys? Seriously, I have no idea. I'm bad at calculations. 42, I guess. So what it would be? Minus 21. And what is this? Minus 5 into 3, minus 15, minus 7. So what it is, guys? 5, 6, 7, right? So what you have here? 7 plus 5. It is 2, 1, minus 22. My God, see how weird calculations are. I mean, I would have done it in simple way, some simple way, but it doesn't matter. Now you have to look for the third entry, right? And below that, everything should be 0. Now what you do, see, here the fourth entry is non-zero. Here the third entry is non-zero. So what you will do, you will again interchange your rows. R3, you will interchange with R4. So what you are get? 1, 3, minus 1, 2, 0, minus 3, 6, 1, then 0, 0, minus 21. This will become your pivotal element. If you haven't observed, you will observe when I will write last row. And below 21, everything should be 0. Below it, everything should be 0, which is true. So this is in fact a row reduced echelon. You may have done it in a different way. This is a row reduced echelon from this metric for this matrix. Okay, I hope you understood it. It's just, calculations. So let us see your B part. It has more rows and more column. I really don't like these calculations. So, but we have to do it. 3, 2, 5, 1, 1, 0, 2. This is 2 minus 6 minus 2, 1. See, this is your first pivotal thing, right? First non-zero entry of first row. Everything below that you have to make 0. So what are the operation? R2 changes to R2 minus 2 R1. R3 changes to R3 minus R1. Similarly, R4 changes to R4 minus R1. And R5 also changes to R5 minus R2 R1, right? So now what is the matrix? New matrix you have is 1 minus 2, 0, 2. Rest everything you have to change. 0. So minus 3 minus minus 2 into minus 2, right? So this is minus 3 minus 2 into minus 2. So what it is? 1. Okay. Now then similarly here, this will remain minus 1. And what is this? 5. Okay. 5 plus minus 2 into 2, which is 1, right? I'm sorry for the noise. Okay, nice. Then what you have here? Just you have to subtract 0, 5, 2, 3. You can check my calculations, I may do wrong. 0, 3, 0, 0. And if I'm doing wrong calculation, it's fine. Okay. Well, you can correct it. And this is 0, then minus 6, minus 2 into minus 2, plus 4, meaning minus 2. And this is again minus 2. And this is 1. This is minus 3. I hope I have not done any, mistakes. Ah, okay. Wow. Go to the second row. Now this will become your pivotal element. It's crucial, right? Because it's pivot. It's crucial because everything is depends upon that element. We are using that element to do something, something, and something. So what will be the operations? Row 3 changes to 5 times row 1, you can minus plus row 3. Row 4 changes to 3 times row 1 minus plus row 4. And row 5 changes to row 5 plus twice row. Something I'm doing wrong. So it should be row. Oh, no, no, it's not row 1, it's row 2. Because this is what my pivotal element is 2. So 2, and this is 2. Okay. Now, what is this, guys? Again, make a matrix 1, minus 2, 0, 2, 0, 1, minus 1, 1. Okay, now this will be 0, 0, 0. This will be also 0, 0, 0, like you have done the construction, right? So what is this? 2 minus 5 into minus 1, meaning 7. This 3 minus 5, meaning minus 2, right? Similarly here, 0 minus 3 into minus 1, which is 3. 0 minus 3 into 1, which is minus 3. And then the last one is, this is, yeah, 2. You are adding 2, right? So minus here, minus 2 into plus 2 into 1, which is 0, minus 2 plus 2 into minus 1, which is minus 4. And this is similarly minus 3 plus 2 into 3. What it is? 3. Like this, right? Okay, very nice. Now you have this, right? Now you have to move on to the next row, and this will be your pivotal element, right? This is 7. Here is 3, but here is minus 3. So now I will give you a trick, so that you can simplify your calculation a bit. What you do, you multiply row 5 by 1 by 3. Okay. Apply this operation. So what matrix you get is 1 minus 2, 0, 2, 0, 1, minus 1, 1, 0, 0, 7, minus 2, 0, 0, 1, minus 1, 0, 0, minus 4, 3. So to simplify calculation, because if I have my pivotal entry 1, that would be bit easy. Now you interchange these two rows. So row 3 interchange with row 4. So what you get is 1 minus 2, 0, 2, 0, 1, minus 1, 1, and then 0, 0, 1, minus 1. So see, you have to also take care of the fact that you're not doing too long calculations. Okay, then what it is? 0, 0, 7, minus 2, and then 0, 0, minus 4, 3. Now you know what to do. Now what is your pivotal thing? This and down this everything you have to make 0. So what will be the operations? The operations will be R4 changes to R4 minus 7R1, and R5 changes to R5 plus 4R, not R1. My God, what I'm doing? 3. I don't know why I stuck to 1, 1, 1 always. It's okay. This is R3. Okay, very nice. So what you get is here. So 1 minus 2, 0, 2, 0, 1, minus 1, 1, 0, 0, 1, minus 1, 0, 0. This will be also 0. This will be also 0. I mean, like how you're doing. And now what will happen here? Minus 2 for this entry. This will change to minus 2, minus 7 into minus 1, meaning 7 minus 2, right? Which is, I think, 5. And similarly here, where? Here, this 3. So it will be 3 plus 4 minus 1. So it is basically minus 1. Now you know what you have to do. What you have to do again, if you want, you interchange the row or just make the 0. So I'm just writing and figure out the operations. 1, 0, 0, 0, 0, minus 2, 1, 0, 0, 0, 0, minus 1, 1, 0, 0, 2, 1, minus 1, maybe minus 1, 0. My choice, what I want to do. Figure out this operations or operation, what I have done. I hope it is clear to you guys. What operation? Your homework. So similarly, I think you can do C and D part that I will just leave as exercise because it's just, you know, calculation. I will rather focus on, uh, you know, um, the next problem, which is somewhat more important. Okay, so question 4. So you have given some systems here, okay, and you have some A kind of thing involved there. You have to find the values of A when the system will have no solution, infinitely many solution, unique solution, these kind of things. Okay. And now let us do the problems. So A, I think the same problem we have already done, or let's do it again if we have done. So x plus y minus z equal to 2, x plus 2y plus z equal to 3, x plus y plus a square minus 5, z equal to a. Let us see. First of all, make its matrix. 1, 1, minus 1, 2, 1, 2, this is 1. Sorry, my z it looks like 2. I will make z other way in the another problem. And this is 1, 1, a square minus 5, a. So since now sir has taught in class about you this row operations and how it corresponds with the matrix multiplication, and you might have seen one special lecture which I have put. So with those logics, I can very well apply row operations here, right? To make it simple. So make it. So R2 changes to R2 minus R1. That will make this 0. It's good to have zeros. And R3 changes to R3 minus R1. So what you will get, guys? 1, 1 minus 2, 2. Let us see what you get. This will be 0, this will be 1, this will be 2, this will be 1, right? This will be 0, this will be 0, this will be a square minus 4. Yeah, I think we have done this problem before and I have proceeded in the same way. And this is a minus 2, right? Very nice. Like I have said you last time also, if you remember, say if you have a row like this, some non-zero number here, b. So what it means, 0 into x plus 0 into y plus 0 into z is what? B, which is non-zero. Is this possible? No. So this is a contradiction. So in that situation, you cannot have x, y, z satisfying all the three equations, right? So using that logic again, so let us make the cases. So case 1. Case 1 would be a square minus 4 is non-zero and a minus 2 is non-zero. Let us, or maybe 0, 0. Yeah, or maybe this case, what I have said. So case 1 is this is 0, but this is non-zero. So what it means, guys, this is 0 means a is plus or minus 2, right? And this says that a cannot be 2, right? Because a minus 2 is non-zero. So this implies a is, using these conditions, a is equal to minus 2. So if is equal to minus 2, then clearly you can again make the matrix if you like to make. I think I should copy that matrix so that I don't have to write the entries again and again. So we'll get minus 4. So this is not possible, right? Contradiction. So in this case, so if a is equals to minus 2, then no solutions. Okay, now what would be the next case? Both of them are 0, right? A square minus 4 is 0 and a minus 2 is 0. Note that you have already exhausted the possibility a equal to minus 2 above. Right? Because from here what you get, a is 2 only. This is the case, right? So that is, let's see what is happening and let me copy the matrix so that I don't have to write again and again things. Oh my God, I cannot copy a simple matrix. Okay, let me copy it like this. Okay, sure. Control plus C. Hmm. So what's happening here? A is 2. So this is 0 and this is also 0. I mean, of course, you have assumed both of them are 0. Right? Let's see what you have in this case. So if you see, you got y plus 2z equal to 1. Okay, y is equals to 1 minus 2z. Okay, 2 I will write like z, but my z will be, I will make z like this. So rest everything is 2. Okay, now onwards. And what we will get from first equation, x plus y minus z equal to 2, right? So what it means, y you already know what it is. Y is 1 minus 2z minus z equal to 2. So what you have, guys, x equal to, you have x equal to, you take everything that side. So 1 plus 3z. So what are the solutions? The set of solutions is this 1 plus 3z. Oh my God. Sorry for bad handwriting. 3z and what else? 1 minus 2z, z, and z is r. So what kind of solutions you are getting? How many solutions you have, right? Z is independent of these things, right? Doesn't depend upon anyone. So at least one variable you are getting which is independent. It can take any value by independent, I mean, and others depend upon that. So that's why they're dependent. So this implies if a is equals to 2, you have infinitely many solutions. So you know what is the remaining case. Case 2 when both of them are non-zero. Basically, case 3 when a square minus 2 is non-zero and a minus 2 is non-zero. In short, a is not equal to plus or minus 2, right? That's all. That's all. Those are the cases which you have exhausted. Okay, let us see what you have here. So control plus V. And what you have is this matrix, of course. So from that, what you will get is a square minus 4 times z from the third row is a minus 2. What it means, guys, z is equals to a minus 2 is non-zero, so you can cancel out both sides, right? So 1 upon whatever, a plus 2. Okay. And from second equations, what you have? Y is equals to 1 minus 2z. So meaning 1 minus 1 upon a plus 2, which is you guys are better than me in calculation. So a plus 1 by a plus 2, I guess. And from the first equation, what you have? X plus y minus z is equals to 2. So this means x is equals to 2 minus y plus z. You substitute these values here. I'm not doing it. I'm very lazy in calculations. Maybe this all plus 1 upon a plus 2. You solve it. What you have? See, depending upon a, once you have chosen your a, which is not equal to plus 2 or minus 2, right? You get something, right? What you are getting? Every value depend upon that fixed a. So how many solutions you have? You have a unique solution. So if a is in real numbers, but other than plus minus 2, then you have unique solution. Okay. Similarly, all of these problems are similar. So let us, discuss something. I don't know why I have taken this problem. Okay. I have taken the A part. So now I will leave for you guys maybe, or maybe let me do some problems. I don't know which to leave and all. So let us do B part. So x plus y plus z equal to 2. 2x plus 3y plus 2z equal to 5. 2x plus 3y plus a square minus 1 z equal to a plus 1. Okay, let us see. Make again a matrix 1, 1, 1. What kind of matrix? Augmented matrix. I'm so sorry. So 2, 3, 2, 5. 2, 3, a square minus 1, a plus 1. Now again, better to start with reduce it in some form. Before that, I want to apply an operation. If you see, this is 2, this is 3, this is 2, this is 3. If I just subtract this, this will become 0, this will become 0. Let's do that. So you see, this is just, simplifying your calculations however you want to do. That's the way. And one way is this row reduced Echelon form or something called Gauss elimination method. What I'm doing is substituting back is this Gauss elimination method only. So 1, 1, 1, 2, 2, 3, 2, 5. So this is 0, this is 0. What will be this, guys? A square minus 3, right? And this is what? A minus what? 4, right? A minus 4, yes. Oh, that's all. We don't need to do anything else. From here only we can decide because A is present in only row 3. So what will be the cases? Again like that. Case 1. A cube minus 3 is 0 and, sorry, A square. A square minus 3 is 0 and A minus 4 is 0. So what are the possibilities, guys? A is equals to plus or minus root 3. Okay, from here. And from here, what you have? A is equals to 4. Is this possible that A cube is 3 also and A is 4 also? No, right? Not possible. So you can never have this row 0. Okay, what is the case 2? It can be 0. Sorry, I think I have done calculations fine, right? Yes, I have done it right. All right. So yes. A square minus 3 is 0. So you see, once you have this 0, 0 kind of row, one row becomes 0. So one variable at least become, sort of independent. So in that case, you have infinitely many solutions. But this is not the case here. So these observation will help you to develop further, what you will study in this course, so, further logics. So let's say this is 0, but a minus 4 is non-zero. Yeah, this is in fact possible. So what you are saying is a square is minus 3 is 0, meaning a is plus minus under root 3, right? Of course, plus minus under root 3 minus 4 is non-zero, right? If you don't know it is non-zero, you can, I mean, root 3 cannot be 4. Why? Because one is rational and another is irrational. Okay, so if you have these A, what is your matrix? Let me copy this matrix. Sorry, my God. Oh, this I should write it very well. Otherwise, this doesn't comes. Okay, control plus C. Let's have control plus V here, and then what you're getting is this is 0, right? And this is something which is non-zero. What it is? Plus minus whatever root 3 minus 4. I mean the two possibilities in both of these values. If it is plus root 3 or if it is minus root 3. Oh, 0 into x plus 0 into y plus 0 into z is some non-zero number. This is not possible. So this is a contradiction. So what you will say? No solution. So if a is equals to plus minus root 3, then no solution. Okay, let us come to the third and the final case if both of them are non-zero. Or will there be any other case? There can be. Think about it. Case 1, case 2. Let's go for the case 3 maybe here. Case 3. So the other possibility is a square minus 3 is non-zero, meaning you have removed those possibilities that a is plus root 3 or minus root 3. But now there are again two cases, right? What about a minus 4? This can be 0, right? It can be 0, meaning a is equals to 4. Let us see what you have in that case. Or it can be non-zero, right? A can be 4 or a cannot be equal to 4. Basically, this can take any value. So what will happen in that case if you look for the third equation? So what you will get is a square minus 3 into z is a minus 4. Whether it is 0 or non-zero, that doesn't matter. From here, I will have a unique value of z, right? Which will be a minus 4, a square minus 3, right? Is not equal to 3. Correct? And similarly, from these equations, you will get the unique value for. Will you get the unique value for? Um, if you want to simplify the solution, just do this thing. I will tell you what. So what you do is, sorry. So yeah, I want to draw. Paste this matrix for a moment. You can in fact, simplify this matrix further if you explicitly want to see what's the solution. So make this 0. So we'll multiply here 2 in the first row and subtract this r2 minus 2 r1. So this will be 1. This is 1 already. And this will be what? 2 minus 2. This is again 0. This is 1. Okay. And 2 is same. Then this is fine. 0. A square minus 3. a minus 4, and then 5 minus 2 is, sorry, 5 minus 2 into 2, right? That is 1. So what you get from here is y is in fact 1. So y is 1. Z is what? A minus 4 divided by a cube minus 3. Now you can find the equation. What is x? X is basically 2 minus y minus z. So 2 minus, 1 minus a minus 4 divided by a cube minus 3, whatever is this. So what you get is either, in either sub case of case 3, if it is a minus 4 is 0, non-zero, doesn't matter. We will have a unique solution. So what's the case? So if a belongs to r minus plus minus root 3, you have unique solution. So either you will have unique solution or you will not have a solution at all. You don't have a case here when you have infinitely many solutions. So these observations will be very useful when you, I don't know if we will taught you that in this course or not, rank and all. So these kind of, examples are very important. Let us do one more. So third, I will leave. No, let me do it. Let me not leave these examples. These are very important. 2x plus 3y plus 2z equal to 5. 2x plus 3y. Oh, I have already taken this one. Okay. C, I will leave as exercise. I mean, you guys can try, right? I have given you all the techniques. Let's do D. X plus y equal to 3. X plus a square minus 8y equal to a. So let us again make the matrix 1, 1, 3, 1, a square minus 8. What will we get here? Let us solve it. So again, you will apply the same operation. R2 changes to R2 minus R1. So this is 0. So a square minus 9. And you have a minus 3. Isn't it similar like your first example? So make the three cases when both of them are 0, when none of them are 0, or at least one is non-zero or the other is 0, like all the cases. So it will depend on the values plus or minus 3. So see and examine the solution. So this is also similar. Basically the problem A and B almost contain all ideas. Maybe if you want I can solve, but I think it's good if you guys do it on your own. So well, this is for today. Thank you very much, guys.